Welcome to Suresh Bhatt classes. We are going to study quantitative aptitude topic average. All the topics of quantitative aptitude are useful for many competitive exams like SSC CGL, Bank PO, RRB, Railways and many government job exams and job interviews. These topics of quantitative aptitude are useful for many entrance exams like GRE, GMAT, CAT, SAT, ACT and many more. Please watch all my videos on quantitative aptitude topics. In this video we start topic average. Average is defined as the ratio of sum of all quantities to the number of quantities. The important formula for average is point 1. If number of quantities or items and the sum of quantity are given, then we can find the average by using the formula shown below. Average equal to sum of quantities divided by number of quantities. If x1, x2, x3 up to xn are values of n observations, then their average is average, which is usually denoted by x bar, equal to x1 plus x2 plus x3 plus, and we go on adding up to xn divided by number of observations n. This formula can be used to solve the numericals on ages, weights, marks, etc. It means that if you have to find the average age of group of people or their weights or the marks obtained by the students in a class, we can use this formula. Now we will solve few examples to understand the average. We go to the examples. Our first example is example 1. Find the average of all prime numbers between 1 and 20. Before solving this example, I request you to please like, share and don't forget to subscribe this channel. Their average is, we first write the prime numbers between 1 and 20. The numbers are 2, plus 3, plus 5, plus 7, plus 11, plus 13, plus 17, plus 19. These are 8 numbers. So we have to divide it by 8. As per the definition of average, it is sum of all the items divided by number of items. Here the items are numbers which are prime between 1 and 20. And before solving this their number is 8. I request sum of these numbers to please like, 2 plus share, 3 is 5, don't forget to subscribe this channel. 10. 10 plus 7 is 17, 17 plus 11 is 28, 28 plus 13 is 41, 41 plus 17 is 58 and 58 plus 19 is 77. So this is 77 divided by 8 and this is equal to 9.625. So the average of all prime numbers between 1 and 20 is 9.625. We go to the example 2. Find the average age of 6 members of a family of ages 65, 63, 40, 37, 16 and 13 years. So their average is, we add all the ages of the family members. This is 65 plus 63 plus 40 plus 37 plus 16 plus 13 and the family members are 6, so we divide it by 6. The sum of all the ages of the family member comes out to be 234 and we divide it by the number of family members, which is 6. 6 divides 23 for 3 times. 6 times 3 is 18. 23 minus 18 is 5. We carry 4, it becomes 54. And 6 times 9 is 54. So the average age comes out to be 39 years. We go to the next example. We go to the example 3. The weights of 8 students in KG are 37, 43, 36, 31, 29, 24, 28 and 44. Find their average weight. Before solving this example, I request you to please like, share and don't forget to subscribe this channel. Average weight equal to, we add all these observations which are 37 plus 43 plus 36 plus 31 plus 29 plus 24 plus 28 plus 44. These are 8 observations, so we divide it by 8. 37 plus 43 is 80. 80 plus 30 is 110 plus 6 is 116. 116 plus 31 is 147. 147 plus 29, which is 176. 176 plus 24 is 200. 200 plus 28 is 228. Plus 44 is 272. We write 272 divided by 8. 8 divides 27 for 3 times. 8 times 3 is 24. 27 minus 24 is 3. And we carry 2. It becomes 32. 8 divides 32 for 4 times. So this comes out to be 34 kg. The average weight of all 8 students comes out to be 34 kg. This way we can solve the questions of average using the basic formula of average. We go to the next point. Point 2, part 1. If a person travels a distance at a speed of x km per hour and same distance at a speed of y km per hour, his average speed for the whole journey is given by the formula average speed equal to 2 times x into y divided by x plus y km per hour. We will learn this formula by one example, and we go to the example. Our example is example 4. A boat travels 48 kilometers downstreams at a speed of 24 km per hour and returns to the starting point upstream at a speed of 12 km per hour. Find his average speed for the entire journey. Before solving this example, I request you to please like, share and don't forget to subscribe this channel. We use the formula of average speed is equal to 2 times x multiplied by y divided by x plus y. Here x and y are the speeds for downstream and upstream respectively, where x and y both are the speed for the same distance of 48 kilometers. So this is equal to 2 multiplied by 24 multiplied by 12 divided by 24 plus 12. This is equal to 2 multiplied by 24 multiplied by 12 divided by 36. 12 divides 36 for 3 times and 3 divides 24 for 8 times. So this is equal to 8 times 2 is 16 km per hour. This is the average speed for the entire journey. This way we can use the average speed formula when distance is same and the same distance is traveled by 2 different speeds x and y. I hope you have understood the use of formula. We go to the next point. Point 2, second. If a person travels 3 equal distances at a speed of x km per hour, y km per hour and z km per hour, his average speed for the whole journey is given by average speed equal to 3x y z, 3 into x into y into z, divided by xy plus yz plus zx kilometer per hour. We will learn this formula by one example. We go to the example. Example 5. A person travels 3 spans of 18 km each at a speed of 6 km per hour, 9 km per hour and 12 km per hour respectively. Find his average speed for the entire journey. We have learned the formula of average speed, which is 3 into x into y into z divided by xy plus yz plus xz. This is equal to 3 multiplied by 6 multiplied by 9 multiplied by 12 divided by 6 into 9 is 54 plus 9 into 12 is 108 plus 6 into 12 is 72. We write numerator as it is, 3 multiplied by 6 multiplied by 9 multiplied by 12, and we take common 18 from the denominator. 18 divides 54 for 3 times, 108 for 6 times and 72 for 4 times. So this will be within parenthesis 3 plus 6 plus 4. Now numerator 3 multiplied by 6 is 18. Numerator 18 is divided by denominator 18. So this comes out to be 12 times 9 is 108. So we write it as 108 divided by 3 plus 6 is 9 plus 4 is 13. So it is 108 divided by 13. So this is 8 whole and 4 upon 13 kilometer per hour. So this will be the average speed for the entire journey. I hope you have understood the method of using the formula for average speed when 3 spans of equal distances are travelled by 3 different speeds. We go to the next point. Point 2, part 3. If a person travels a kilometer at a speed of x kilometer per hour, b kilometer at a speed of y kilometer per hour and c kilometer at a speed of z or z kilometer per hour, then his average speed for the entire journey is given by formula average speed equal to a plus b plus c. What is a plus b plus c? Is the total distance divided by a upon x plus b upon y plus c upon z. What is a upon x? Is the time taken for distance a. What is b upon y? It is time taken for distance b by speed y kilometer per hour. And what is c upon z? Is the time taken to travel distance c by z kilometer per hour. So c upon z is the time. So a upon x is time plus b upon y is time plus c upon z is time. It means it is the total time for the entire journey. So the average speed is total distance divided by total time. And this average speed is kilometer per hour. We will learn to use this formula by one example. We go to the example. Example 6. A person travels 8 km at a speed of 4 km per hour, 15 km at a speed of 5 km per hour, and 18 km at a speed of 6 km per hour. Find his average speed for the entire journey. We use the formula average speed equal to A plus B plus C. This is the distances divided by A upon X plus B upon Y plus C upon Z. These are the time for distances A, B and C. So we put the values. A equal to 8 km plus B equal to 15 km plus C equal to 18 km divided by the time for 8 km is 8 upon 4. 4 is the speed plus B upon Y is 15 upon 5 and C upon Z is 18 upon 6. This is equal to 8 plus 15 is 23. 23 plus 18 is 41 divided by 8 upon 4 is 2 plus 15 upon 5 is 3 plus 18 upon 6 is 3. So this is equal to 41 divided by 2 plus 3 is 5 plus 3 is 8. And this is in mixed fraction 5 whole and 1 upon 8 kilometer per hour. This is the average speed for the entire journey. I hope you have understood the concept as well as the use of the formula. Here I request you to please subscribe to this channel if you have not subscribed it so far. We go to the next point. Point 3, part 1. If group A with a number of students A and average X and group B with number of students B has average Y, then average for the total students equal to A into X plus B into Y divided by A plus B. Here what is A into X is the total of number of students A plus B into Y is total of number of students B divided by total number of students. Here X is the average. It may be average weight, it may be average age, or it may be average marks of group A or group B with number of students A and number of students B. I hope you have understood the formula. Now we will solve a question to understand this formula. Our example is example 7. The average weight of 16 girls and 24 boys of 5th class is 25 kg and 30 kg respectively. Find average weight of all the students of the class. Before solving this example, I request you to please like, share and don't forget to subscribe this channel. We use the formula to solve this question. Average weight equal to AX plus BY upon A plus B. We put the value. A is 16 girls and their average weight is 25 kg. So it is 16 multiplied by 25 plus there are 24 boys. So it is 24 multiplied by 30 because 30 is their average weight divided by 16 plus 24. It is the total number of students, 16 girls and 24 boys. So this is equal to 16 multiplied by 25 is 400 plus 24 multiplied by 30 is 720 divided by 16 plus 24 is 40. 400 plus 720 is 1120. divided by 40. We cancel the zeros of the denominator and numerator. 4 divides 112 for 28 times. 4 times 2 is 8. 11 minus 8 is 3. We carry 2, it becomes 32. 4 divides 32 for 8 times. So this is equal to 28 kg. The average weight of all the students of the class is 28 kg. I hope you have understood the formula as well as solution of this question. We go to the next point. Point 3, part 2. Group A with number of students A has average X, and Group B with number of students B has average Y. If Group B is removed from Group A, then average of remaining students A minus B equal to AX minus BY upon A minus B. Here Group B is part of Group A, and if the number of students of Group B is removed from the total number of students which is of Group A, then their average will be AX minus BY upon A minus B. Now we will understand this formula with one example. Example 8. The average weight of 50 students of class 5th is 30 kg. If average weight of 20 girls is 27 kg, find the average weight of boys of the class. We will use the formula average weight equal to AX minus BY upon A minus B. This is equal to A is the total number of students, which is 50, multiplied by their average is 30, minus number of girls, which is 20, and their average weight is 27. So it is 20 multiplied by 27. Now number of students total is 50 minus number of girls is 20. So this is equal to the average weight of the boys. 50 multiplied by 30 is 1500 minus 20 multiplied by 27 is 540 divided by 50 minus 20 is 30. 1500 minus 540 is 960 divided by 30. We cancel the 0 of numerator by 0 of denominator, and 3 divides 96 for 32 times. So this is equal to 32 kg. The average weight of boys of the class is 32 kg. I hope you have understood the formula as well as use of formula for solving such type of questions. We go to the next point. Our next point is short tricks. Point A, part 1. Average of first n natural numbers equal to n plus 1 upon 2. And based on this formula, the example is example 9. Find the average of first 55 natural numbers. Before solving this example, I request you to please like, share, and don't forget to subscribe this channel. Using the above formula, our average equal to n plus 1 upon 2. N is 55. So we write 55 plus 1 upon 2 equal to 56 upon 2. This is equal to 28. So the average of first 55 natural numbers is 28. We go to the next point. Point A, part 2. Average of squares of first n natural numbers equal to n plus 1 multiplied by 2n plus 1 divided by 6. And using this formula, we will solve the example 10. Find the average of squares of first 35 natural numbers. So average equal to, here n is 35. So n plus 1 will be 35 plus 1 multiplied by 2n plus 1. So 2 multiplied by 35 plus 1 divided by 6 is equal to 35 plus 1 is 36 multiplied by 2 into 35 is 70 plus 1 is 71 divided by 6. 6 divides 36 for 6 times and 6 multiplied by 71. 6 times 1 is 6 and 6 times 7 is 42. So the average of squares of first 35 natural numbers is 426. I hope you have understood the formula as well as the use of formula by solving this question. Point A, part 3. Average of cubes of first n natural numbers equal to n into n plus 1 whole square divided by 4. And we will use this formula to solve the example. Example 11. Find the average of cubes of first 17 natural numbers. Here n equal to 17. So we use the formula average equal to 17 into 17 plus 1 whole square divided by 4. So this is 17 multiplied by 17 plus 1 square is 18 multiplied by 18 divided by 4. 2 divides 4 for 2 times and 2 divides 18 for 9 times. Again 2 divides 2 for 1 time and 2 divides 18 for 9 times. So this is equal to 17 times 81. 17 times 1 is 17. We carry 1 and 17 times 8 is 136 plus 1 is 137. So this is equal to 1377. So the average of cubes of first 17 natural numbers is 1377. I hope you have understood the formula as well as solution of the question using the formula. We go to the next point. Point B, part 1. Average of first n even numbers equal to last even number plus 2 whole is divided by 2. The other formula for this is average equal to n plus 1. We will learn both the formula by the example. Example 12, part A. Find the average of 2, 4, 6 and the last number is 44. Or the same question can be asked as part B. The above question can be asked as find the average of first 22 even natural numbers. Now we solve this question with the above two formula. The part A, the last even number is 44. So 44 plus 2 divided by 2. 44 plus 2 is 46 divided by 2 is 23. So the average of 2, 4, 6 up to 44 is 23. And the same question if asked as find the average of first 22 even natural numbers. So 22 is the number of terms which is n. So the average will be 22 plus 1 equal to 23. I hope you have understood the question and method of solving using the above formula. We go to the next point. Point B, part 2. Average of first n odd natural numbers equal to last odd number plus 1 divided by 2. The other formula for this is average equal to n, which is number of odd natural numbers. And we will learn to solve the question using the above two formula. Basically, both are the same. Example 13, part A. Find the average of 1, 3, 5 up to 41. Or the same question can be narrated as the above question can be asked as find the average of first 21 odd natural numbers. Both are basically the same question. Here the numbers are given and here the total number of odd numbers is given, which is 21. Before solving this example, I request you to please like, share and don't forget to subscribe this channel. We will solve this question by the above two formula. The last odd number is 41 plus 1 divided by 2 is 21. 41 plus 1 is 42 divided by 2 is 21. So the average of 1, 3, 5 up to 41 is 21. Or the same thing is asked as find the average of first 21 odd natural numbers. As here the value of n is 21, so the average is also 21. I hope you have understood the question as well as formula for solving it and the formula. We go to the next point. Point C, part 1. If value of each term increases or decreases by x, then the average of the group also increases or decreases by x. And we will learn it through example. Example 14. The average of 6 numbers 6, 11, 16, 23, 25 and 27 is 18. Find the average if part A, each number is increased by 7. Part B, each number is reduced by 5. If each number is increased by 7, then 6 becomes 13, 11 becomes 18, 16 becomes 23, 23 becomes 30, 25 becomes 32 and 27 becomes 34. We take the sum of these numbers. 3 plus 8 is 11 plus 3 is 14. 14 plus 2 is 16. 16 plus 4 is 20. We write 0 and carry 2. 2 plus 1 is 3. Plus 1 is 4. Plus 2 is 6. Plus 3 is 9. Plus 3 is 12. Plus 3 is 15. So this sum is 150. And if we have to take the average, then 150 divided by 6 equal to 25. It means that if every number is increased by 7, then average also increases by 7. The earlier average was 18 and now the average is 25. And that proves the point C, part 1, which says that when any number is increased by x, then their average also increases by x. Now we go to the part B of it. Every number is reduced by 5. Then 6 becomes 1, 11 becomes 6, 16 becomes 11, 23 becomes 18, 25 becomes 20 and 27 becomes 22. Now their sum. 1 plus 6 is 7, plus 1 is 8, 8 plus 8 is 16, 16 plus 2 is 18. We carry 1, 1 plus 1 is 2, plus 1 is 3, plus 2 is 5, plus 2 is 7. Now average, if we have to find, then we divide 78 by 6. 6 divides 78 for 13 times. The earlier average was 18. Now if we reduce 5 from 18, we get 13. And this also shows that when each number is reduced by 5, the average also is reduced by 5. So by this we learn that instead of adding or subtracting any given number to each number and then finding the average, we can directly increase or reduce the given number from the average and get the answer without solving all these. We go to the next point. Point C, part 2. If value of each term is multiplied or divided by x, then we get the new average of the group by multiplying or dividing old average by x. And we learn this by example 15. The average of 7 numbers 9, 14, 19, 21, 26, 28 and 30 is 21. Find the average if part A, each number is multiplied by 4. Part B, each number is divided by 3. Now, instead of multiplying each number by 4, then adding them and then finding their average by dividing it by 7, in solving part A, what we do? We just multiply 21 by 4 and our new average will be 84. And in part B, instead of dividing each number by 3, we directly divide 21 by 3 and get our new average, which is 7. This is the direct solution method or short trick for solving such type of questions. We can verify it also. In part A, sum of the given numbers is 147. If we multiply each number by 4, it means that we are multiplying their sum by 4. And if we divide it by 7, then this is also equal to 21 multiplied by 4. And this is equal to 84. Also, in part B, if we divide 147 by 3, we get 3 times 4 is 12, 14 minus 12 is 2, we carry 7, 3 divides 27 for 9 times. And when we divide 49 by 7 for finding the average, we get average equal to 7, which is 1/3 of 21. It means that whenever such type of questions are asked in any competitive exams or entrance exams, we should directly multiply or divide the old average by the given number to find the new average. We go to the next point. Point D. If we know average of two groups individually, then the average of combined group cannot be determined. We will learn it by one example. Example 16. The average of group A is 21 and group B is 10. Find the average of combined group A plus B. This cannot be determined as data is insufficient. But if we add the missing data, then we can solve it. Here, the average of group A is given, which is 21. And also, the average of group B is given, which is 10. But this average is for how many observations that we don't know in A or B. The number of observations of A and number of observations of B is not given. So we cannot find the combined average of group A and B. Now the modified question is, the average of 7 numbers of group A is 21 and 4 numbers of group B is 10. find the average of combined group A and B. Now it is possible, as the number of observations of group A, which is 7, and number of observations of group B, which is 4, is given. Now we can easily solve it. Before solving this example, I request you to please like, share, and don't forget to subscribe this channel. The average equal to AX plus BY divided by A plus B. Here A is the number of observations, which is 7 for group A, and their average X is 21, plus the number of observations of group B is 4 and their average is 10. So we write it as 4 multiplied by 10 divided by 7 plus 4, and this is equal to 147 plus 40 divided by 11, and this is equal to 187 divided by 11, and this is equal to 17. This way, if the data is insufficient, we cannot find the average, but if the data is sufficient, then we can find the average. I hope you have understood this point. Now we go to the next point. Point E. In arithmetic progression, if number of terms are part 1 odd, average is the middle term, and if number of terms are even, average is the average of two middle terms, and we will learn it by example. Example 17. Find the average of part 1, 3, 7, 11, 15, 19, 23, 27. This is an arithmetic progression, and the number of terms are 7 here, and 7 is odd number. It means that the average of these terms will be middle term, and middle term is fourth term, which is 15. So the average will be 15. And in part 2, the terms are 1, 4, 7, 10, 13, 16, 19 and 22. This is also an arithmetic progression, and the number of terms are 8, and 8 is even number. So we have to find the average, which will be the average of the middle two terms, and middle two terms are 10 and 13. So we will find the average of 10 and 13. 10 plus 13 divided by 2. This is equal to 23 divided by 2, and this is equal to 11.5. This way, if the number of terms are odd, the average will be middle term, and when the number of terms are even, then their average will be average of the two middle terms. I hope you have understood the short trick of finding the average or mean of arithmetic progression. We go to the next point. Point F, part 1. Let the average of n quantities be x. When a quantity be added, the new average becomes y. Then the value of added quantity equal to n multiplied by y minus x plus y. Here x is the initial average and y is the final average. So this is n multiplied by final average minus initial average plus final average. This we will learn by example. Example 18, part A. The average age of 25 students is 10 years. If teachers' age be added, the average becomes 11 years. Find the age of the teacher. So teacher's age, n is 25, final average is 11, minus initial average is 10 plus final average 11. This is 11 minus 10 is 1. 1 multiplied by 25 is 25 plus 11 is 36. So the teacher's age is 36. I hope you have understood the formula as well as use of formula. Here the average age was increasing. Now we go to the next question, which is part B of the question. Here the average age is decreasing. So we go to the question. The average age of 10 boys is 15 years. If a child's age be added, the average becomes 14 years. Find age of the child. Now here the average is decreasing. Child's age equal to, here n is 10. Final average is 14. Initial average is 15. So 14 minus 15 plus final average, which is 14. This is equal to 14 minus 15 is minus 1. And minus 1 multiplied by 10 is minus 10. And minus 10 plus 14 is 4. So child's age is 4 years. You have to keep in mind that we have to subtract initial age from the final age, whether it is positive or negative. If it is negative, we will take it negative. If it is positive, we will take it positive. When the average age is increasing, then it will come positive. When average age is decreasing, it will come negative. And we will get our answer by using the positive or negative sign. I hope you have understood the use of the formula and how to solve the question using the formula. We go to the next point. Point F, part 2. Let the average age of n quantities be x. When a quantity be removed, the new average becomes y. The value of removed quantity equal to n x minus y plus y. Here x is the initial average and y is the final average. This quantity may come negative or positive. If the average decreases, then this quantity will be positive. And if the average increases, then this quantity will be negative. And we will use whatever the value comes, whether it is positive or negative, we will take it as positive or negative and we will reach to our answer. We will learn it by examples. Before going to the examples, I request you to please like, share and don't forget to subscribe this channel. Example 19a. The average age of 34 students and a teacher is 10 years. If teacher's age is excluded, the average age of students becomes 9 years. Find age of the teacher. So teacher's age equal to n is 35. 34 students plus 1 teacher is 35. Initial average was 10 years and when the age of teacher is removed, the average becomes 9 years. So the final average becomes 9 years plus 9. Now 35 multiplied by 1, 10 minus 9 is 1. So this is 35 plus 9 equal to 44. So teacher's age is 44. I hope you have understood the method of solving it. Example 19b. The average age of 12 boys, including a child, is 18 years. If child's age is excluded, the average age of remaining boys becomes 19 years. Find the age of the child. Child's age. equal to, here n is 12. Number of total boys including child is 12. So n equal to 12. Now the initial average is 18 years. And when age of child is excluded, the final average becomes 19 years. So it will be 18 minus 19 plus final average, which is 19. This is equal to 12 multiplied by 18 minus 19 is minus 1. So this will be minus 12 plus 19. Minus 12 plus 19 is 7 years. So child's age was 7 years. I hope you have understood. The value of x minus y may be positive, may be negative. Whatever it may be, we have to use that. If it is negative, we will use it as negative. If it is positive, we will use it as positive to reach to our answer. I hope you have understood the formula as well as the use of the formula. Here completes the introduction of average. Now we will be solving many questions on average to become experts in solving the questions of average. Please watch all my videos on quantitative aptitude topics and do lot of practice from different books by solving questions of quantitative aptitude topic. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.